IP source guard gives you the ability to ensure that IP addresses are not being spoofed in the network. So for example, if we analyze our topology of PC1, PC2, and PC3, their IP addresses are 10.11.10, 10.11.20, 10.11.30. We want to make sure that when packets are sourced from any one of these devices, it is that IP address that is being used. We don't want PC1 to say, hey, I'm going to send this packet using 10.11.20, or I'm going to send this packet using 10.11.5, or even 10.11.1. No, we don't want that to happen because that's IP address spoofing. So we can configure IP source guard to check that information and make sure it's valid information. But how does it know what is valid and what is not valid? Well, it's based on DHCP snooping. Because DHCP snooping creates a binding table, that information in the binding table can be utilized to determine where each device is within the network. So if we look at the output of show IP DHCP snooping binding, we'll see in this binding table that out of fast Ethernet 0/1, the device with the IP address of 10.11.10 exists and the MAC address of 06D6 exists. So with that in mind, we can leverage this table. We can leverage this information and now make sure that the packets that are coming inbound from that device has a source IP address of 10.11.10. If it's anything but that IP address, then those packets are not legitimate. They will not be accepted. So since DHCP snooping needs to be up and operational, we're going to have to verify with IP source guard issues that DHCP snooping is working first. So was it enabled globally? Is it enabled for the correct VLANs? And we can verify that both with the show IP DHCP snooping command. So we go back to ASW1, show IP DHCP snooping. We'll see that it is enabled globally right here, and we can see that it's been enabled for VLAN 10 as well. And then after that, if we want to verify if IP source guard recognizes the IP addresses on the interfaces, we can use the show IP verify source command. So if we look at the output of show IP verify source on ASW1, we'll see from this output that the filtering type is simply based on IP. So we only care about the IP address in this particular case. And the filtering mode is active for VLAN 10, and the IP address on fast Ethernet 0/1 is 10.11.10. Now there's another device, a virtual machine on PC1 as well. It's using the IP address 10.11.32. And so you can see, we'll accept packets from both of these IP addresses on fast Ethernet 0/1. If a packet is sourced from any other IP address and it's coming inbound on fast Ethernet 0/1, it won't be allowed. It won't be allowed through. Now the filtering type can be modified. We can modify that filtering type to IP and MAC. So if you want to enhance the security a little more, you can filter based on both the IP and the MAC. However, in order to accomplish that, port security must be enabled and running on that particular interface. So it relies on port security there as well to verify that particular MAC address that is going to be used and learned on that interface. So if you're troubleshooting IP source guard, you're looking for issues related to DHCP snooping, and you're looking to make sure that the interface has been enabled for IP source guard. So what's the command to enable the interface for IP source guard? Well, let's look at the output of show run interface fast Ethernet 0/1. We'll see the command is listed right here. It's IP verify source. That is if you want it just to look at IP addresses. If you want it to look at both IP and MAC, the command is going to be IP verify source port security. And if we look at the output of show IP verify source, now we'll see that it's IP and MAC, and the MAC address is listed as well in the output. So only frames coming from this MAC address and packets coming from this IP address are going to be accepted inbound on fast Ethernet 0/1. Everything else is classified as a spoofed frame or packet.